The following content is for entertainment and educational purposes only. It does not constitute means for diagnosis, healthcare advice, nor treatment. Make use of a qualified healthcare professional for such purposes.
There's two kinds of descriptive statistics. The descriptive statistics come in two different types. Central tendency, and what's the other one? Variability, that's right. So these are your three measures of central tendency that we use most often. You got the mean, which is represented by italicized M. That's just the average. And the mean is the basis of all parametric statistics, right? Because we're comparing means is what we're doing with parametric statistics. And it's best for interval ratio data. The median is the midpoint. It's handy if you have outliers or skewed data. It's also good for ordinal data. The mode is the most frequent number in a data set. And that's the only option that's acceptable if you have nominal data. If you're a dependent variable, if you're collecting nominal data, the only thing you can report for descriptives is mode. Okay? So if you have a normal distribution, you've got in the center the mean, that's right. But what's also in the center, if it's normal, is the median and the mode. They're all equal in a normal distribution. Okay, and how I talked about the median being useful, if you had a distribution where, like, let's say you were reporting salaries, right? And let's say everybody that graduated from the geology department, University of North Carolina, had an average salary of $150K. But let's say this was the distribution, because guess who graduated from UNC that year? Michael Jordan. And his salary that he's reporting is way higher than all these other geology graduates, right? So if we were to just take the average, right, that wouldn't really represent what most people's salary is that graduated from the geology department that year, right? So that's where we would think about using these other, we made that a little bit too close there. The mean would be here. The mode is always at the top where it's the highest, and then the median would be right here. And it would be a better representation because it's not affected by this. It's just the middle number. So we've also got measures of variability. The options for those, if you're talking about parametric statistics, is the standard deviation, which is abbreviated SD in italics, is the average distance from the mean of the distribution. The standard error, right, it accounts for the sample size. Here's the equation for it, and you can see that sample size is included. So the sample size contributes to the standard error. And then for non-parametric statistics, we've got the range, right? So don't forget the lonely little range out there, right? That's another measure of variability. So here's an example of why variability is important. Let's say, for example, demand is really high for lunchbox-sized apples, tiny apples that you can fit in your lunchbox, right? And let's say we need the apples to be able to fit in most lunchboxes to be 4.5 to 5.5 inches in diameter, very small, right? 4 inches is too small. Nobody's gonna want to buy them because they're too small. 6 inches is too big, won't fit in the lunchbox, right? So we got a farmer who wants to experiment with hybrid apple trees to see what crop is going to give him the most apples in that little range, right? So he's got 3 types of apple trees, 3 hybrids, right? He's got this yellow tree, the blue one, and the red one, right? Which tree do you think he should pick so that he can get, let's say that the mean right here is 5 inches. This is a 5-inch diameter apple, right in the middle of the range he wants. Which distribution is going to work the best for him?
Yellow.
That's right, the yellow one. Why is that? Because most of the apples are really close to the 5 inches, right? If he picks this one, he's going to have a ton of apples that are too big and too small.